I'm gonna be switching to English now, so hopefully it's okay with everybody. My name is Luciano Resende. I work as a data science platform with the CODAIT group. Basically, it stands for Center of Open Source Data and AI Technologies. For those that knew about the Spark Technology Center, that's kind of our former name, and now with CODAIT we're starting to kind of like increase the scope of our contributions. If you want to reach me later on for questions or anything, these are kind of like where you can find me. What are we going to be talking a little bit today? Because we are pressed a little bit with time, I'm going to skip some of the things that we touched on in the introduction, and we're going to be talking about open source data at the CODAIT group, model asset exchange, fabric for deep learning, and Jupyter Enterprise Gateway. Before I get started here, like show hands like who have already been working on kind of like AI recently. Machine learning. Saying, oh, a little bit more, okay. So yeah, I'm gonna try to do some introductions on things that can get the others to be able to get started more easily and start kind of like playing with the technologies in a much simpler way. I'm gonna skip here, but mostly just talking about IBM, some of the contributions that we do. We have things like for learning, consuming, contributing, connecting. We do a lot of things. Sometimes people don't make the connection of IBM with things that are open source and available for free, but we actually do a lot of the things in the open source. Some of the areas that we contribute. So we have what we call like a code open, and we actually start some open source projects there. It's available for free for people to go and browse and take a look. We contribute to kind of like strategic community. Those are kind of like some areas that we have identified where we want to focus. It's not only that area, but that's kind of like strategic areas that we are contributing to. And also, we have developed across the years a lot of like best practices and kind of like guides on like how to contribute to open source, like all the things around like licensing and things like that. We also have open source so other folks can use that as a template or just kind of like a informational to kind of contribute if you want to start contributing to open source. So let's start and switch focus to CODAIT. Let's start with like some of the historical contributions that IBM has been doing around AI, particularly like IBM research that like since kind of like around 68, we were already like a technical advisor when the film Space Odyssey was created. We then forward a few years after that, we saw that Deep Blue won the first chess game. More recently, Watson won Jeopardy, and culminating more towards today, the kind of like open tech, AI emerging standards areas that we want to contribute, and CODAIT is one of the groups that are working on that area and bringing open source AI technologies to the open source world. What is kind of the mission for CODAIT? Basically aims to make AI solutions much easier to create, deploy, manage in the enterprise. As I mentioned, we kind of came as an evolution from Spark Technology Center, which was created around 2015. So we started like doing contributions just around the Spark Technology Center and expanding to AI technologies. We mentioned here a little bit of like already areas that we have been working. I think if I go to the next slide, maybe it makes more sense here. And we want to make sure that we excel in contribution of the code speaks. We also want to contribute content and build communities around these areas. And if you look at the diagram that we have here, we're starting to concentrate on kind of like the AI life cycle, where you see basically gathering data, analyzing, then doing machine learning or deep learning, deploying the model, sorry, and then kind of like considering that scope, then you see some of the technologies and areas that we have been working. So we continue to work on Apache Spark, kind of like that data manipulation area, and also like around machine learning. When we start talking about deep learning, we start seeing a lot of like other technologies being embraced on that area. So like TensorFlow, Keras. We have created model asset exchange, where we're going to be talking next, and also Fabric for deep learning that is coming from a collaboration between our group and the Watson and research group. And also things around Pandas, scikit-learn, and Jupyter notebooks in general. So all in the context of like the AI model lifecycle. So what is kind of model asset exchange? The goal here is to start enabling domain experts to use deep learning in the enterprise. When we look again on the diagram, model asset exchange is kind of like right in the middle around deep learning, and that's what it tries to help. And let's try to make an analogy here. So like today, we pretty much have telephones everywhere. Maybe it's a voice over IP phone, it's a cell phone, or something like that. And although to us might seem a little bit of like magic of like how things work inside, everybody feels very okay to use the telephone, knows how to call someone, browse and do something. And that's kind of the analogy that we want to start bringing to deep learn. Even though it's a very complex and inside it's like some things very hard to understand or involving multiple different technologies, we want to start making it very, very easy for you to be able to consume that and start bringing value to your applications, to your corporation, and things like that. When we start talking about deep learning, and kind of like the first thing is like, what is deep learning? I could spend like an hour or two trying to go into some of the details, but let's just kind of like think as a machine learning using deep neural networks for the context of like this talk. And if we start looking like into some of the characteristics of deep learning, so algorithms for image classification, machine learning translation, facial recognition, time series predictions, those are kind of like some of the areas that people and algorithms are coming up on this area. If we look into an actual kind of like a model, basically large and very complex models, it usually tries to be kind of like the scope is kind of like what are the amount of resources that you have available to kind of like train that model. The more you give, the more it can consume, and it can really like grow very big. And this is just an example here. We have kind of like a 32 and between 32 and 768 linear regression models in this kind of like model that we are seeing here. Another example is, and this is the part kind of like I kind of like call it magic. And even though you can talk even to some of the experts here, we know that things are converging, that things are kind of like all going in the same direction. Sometimes we don't know exactly why it's that. And you can see, like, for example, when you look into some of the kind of papers that have been written on this subject, and you see that, well, even the expert, the guy that wrote, saying, well, while the results are encouraging, still like questions remain on the exact dynamics at play. So we want to start applying the same concepts and bring kind of like a easier user experience to people start using, consuming these models. Sounds easy, right? Everybody knows how to use a telephone. It's just like click some numbers and that's it. So let's take a very quick example, very simple as well. And we want to give an image to a model, and you want to kind of like identify if it's actually like a cat or a dog. So you need a driver program, a neural network graph, and kind of like some weights to kind of help you guide there. And at the end, you expect kind of like a result that describe what that image is. So how do we start getting that kind of like example implemented? So first, we need to find kind of like a suitable neural network graph. If you look at kind of a Google Scholar and just do a quick search, the amount of like research papers that come out just around that topic is huge. So you start having to read some papers, so you kind of like define or get some information that kind of enables you to start moving along. You have to have some to find some code that generate a neural network graph for you. This is an example of like how big the code is for TensorFlow implementation of like a ResNet 50. And one second here. You also need to work like on finding some pre-trained weights for your graph. So this is an example, and you can see like a huge size for Café implementation of ResNet, the model weights. So you need to start kind of like being able to perform the inference and being able to actually get some of the results of that. You need to implement that part as well. This is just an example of TensorFlow that trains and do a batch inference. And you're just doing like one image, so you want to just be able to tweak that a little bit, then package all of that, deploy, and be able to kind of like infer. So if you see, these are very, it's a lot of steps, and just for one type of scenario. And if you have to spend like all the time to do all of that, it's kind of like hard to get just started with deep learning. So some of the things that we are seeing recently is kind of like a model marketplaces. And what is that? It's basically like a one place where start giving you kind of like a set of like well understood deep learning models. They curate those models and make those available in a kind of simple way to access and use. And you can easily start working on that. An example of like a model marketplace is Model Asset Exchange. We call it for short MAX. What we have done with MAX is, and it's kind of like an initial release. So we have the models. We don't have like a very large set of models, but we are constantly keep increasing that. But it's kind of like a one-stop and shop where you can come and you can see all those models. We try to make them consistent in the way that you can deploy and start using that when possible, when the models and the data license enable us. We also give you the ability to train the model, so you can start maybe like bringing some of your own data to have more specific result sets coming from that model. I've talked a lot, so let's try to kind of like see how it works now, and that can give you guys a little bit more like a hands-on type of experience, and you guys can see that once you get home, it's going to be very easy to start playing with deep learning. Now I have to start switching things here. Okay. Okay, so when you go to www.codait.org, you're gonna get to our kind of like main page. I think the resolution is a little bit big here, but you see that the main projects that we are working on, and one of those is gonna be the model asset exchange. And you can just click there and you basically come to this page. This page we list all the models that we have available, and it's an easy way to kind of like as a catalog of the models, and you can get redirected to the actual model from there. So we have, like, for example, object identification models, we have like image classifiers, caption generators, and many more. Some of these are just trained and then ready for you to start kind of like inferring. In others, you have the ability to train. We provide kind of like scripts that can do a one-click training in for example, like Watson Studio and DLAS, or you can start training on some of your own resources. As an example for this demo, we're just going to use the image caption generator. I have opened here already, so when you click on that, you will come to a GitHub repository. All the models that we currently have is available inside the github.com/IBM, and it's prefixed by Max. And this is the image caption generator. We then describe here like very detailed like how you can start using that. But not only that, we provide all the references in terms of like if you want to understand a little bit more of like the internals of the algorithm. We also have done a due diligence in terms of like the legal aspects and all the license for the model, for the data, and all the involved pieces on that particular model. Here we require Docker because we are using Docker to kind of wrap into a consistent pattern for better usage. And then you have all the details here to start building the model and etc. So if we go and try to use, and then let me, so I have like quick steps here that I need to do. So very simple, we can just do a Docker run that will start the model. The model will be exposing a REST API that you can then usually, you can just easily like post, let's say, an image there, and you'll get the results back. So just here I have some sample images that I do. And in this case, let me see. So you see that like I posted an image and I start seeing kind of like the caption that was generated. So a group of people sitting on a sandy beach, or a group of people sitting on top of a beach. And let me see, I think it's good if I try to show the picture as well. So let me just try here. What was the number? 5337. 5337, so this is kind of like the image that I submitted there. But you can see that the way that you start communicating with that and being able to consume that AI algorithm is something that, like, for people that are building, let's say, web apps or just familiar with like how HTTP works, it's easy for you to start consuming and leveraging all the power of AI. And now let's take a quick look. So the other example that we're starting to build is like how then you leverage that to build an application. And I have started the application here already. Let me go here. Let's take a quick look. And what you start seeing is basically a set of images that I have allocated for the app, and you start seeing that all these images now kind of like have a caption. You can start, for example, doing like search on top of that. It makes the experience and some of the capabilities, enhance the capabilities that your application can start having by applying, utilizing the deep learning capabilities that we are exposing with these models. In terms of demo, let me go back to slides here. And one thing to mention is like all of this is all open source. So like you can all go to the GitHub, go to the things that we have, we are showing here, and all the source code is available, all the steps and everything for you to start using, modifying, and start basically leveraging that.
I'm coming back.
Okay.
I'm recording at the same time.
Okay. So just a quick summary around Max. Free open source models, variety of domains, multiple deep learning frameworks. We have TensorFlow, Caffe, and others that we have models there. So vetted and tested like code and IP. So we do a due diligence, we make sure that everything is working, but it's also like the legal aspect is all well and good for consumption. And it's something that you can very quickly start building and start using that. And also for the ones that we have the ability to train, you can just easily train on like Watson Studio and other platforms. Some of the things that we're gonna do with Max is like, as I mentioned, creating more and more models, making more models available, revamp the website. We know that as it grows, we need capabilities for like searching and doing kind of like finding the model that you need more easily. Integration with Watson catalog, and also like being able to upload models and get things going. One of the things that we also mentioned here is like train in Watson Studio and DLAS and run inferences on the IBM infrastructure. This is something that we are working on, but kind of like if you can't wait much, the existing models are already, all the Docker images are already available in Docker Hub for you guys to use. And it's very easy to create, for example, like a Kubernetes deployment descriptor. For the one that we are using today, I already created one and checked it in. And with the slides, I kind of like have like a useful set of commands that you can easily go and use that will deploy that model in, for example, the IBM container services, and then you can easily like run the app against the services that are running on the IBM infrastructure. And here gives all the commands that you need to get into that stage. So we saw about the models, we saw like how complex the internals of it can be. But now, so if just to get another model is a complex task, how about like when we have to train the model? Fiddle, which is kind of like the short for Fabric for deep learning, kind of tries to help solve that type of problem. It provides a scalable, resilient, and fault-tolerant deep learning kind of like framework for you to start building your models, training your models. When we start looking to these models, the example that we did today kind of like only go from like one framework. When you start like seeing that we have a TensorFlow that uses one way of like set of APIs, one way of like serving the models, and then when you go and multiply that by the number of like available frameworks, or at least not only the available ones, but like at least just the set that is kind of like more popular, you start seeing that it starts becoming very complex. Like if you are a data scientist, you have to understand all that model part, and now you have to start understanding all the kind of like infrastructure part to be able to build an environment that enables you to run and train your model there. And for example, if you are a DevOps guy and you need to manage and kind of like support all that infrastructure, you need to understand how all the different frameworks kind of like work, and like what are the implications. You have to like be able to start sharing the resources, like the GPUs, in a good way, and not try to waste some of the resources, and all of these kind of things. Fiddle tries to help there. For the data scientist, it tries to really like abstract that and provides like a very kind of like consistent API for you to start building your models and running experiments independent, kind of like which of the frameworks that you're using. In terms of the DevOps, it tries to help the management of those environments. We also, Fiddle is built on top of like Kubernetes, which gives you a lot of the benefits that you get with Kubernetes in terms of like resilience. If something gets stopped, Kubernetes help kind of like bring it back and all this kind of stuff. So we leverage all the power of Kubernetes, and we start giving you kind of like a simple way to manage the deep learning environments for your data scientists. And for them, we provide kind of like a consistent API across all the frameworks to start training the models. Yeah, I've mentioned already, this is some of the UI, some of the components involved in Fiddle. I mentioned a part of the Kubernetes. Another thing is we open source Fiddle, but we also like leverage Fiddle into what we call the deep learning as a service, which is a Watson Studio, part of Watson Studio at the IBM Cloud. So it's something that has been tested, we have been running in production. So it's kind of like a stable, and you can start playing. It also gives you the ability to maybe just getting started in the open source, and then once you actually need some kind of like a GPUs or scale to a better, more powerful hardware, you can easily kind of like just move to kind of like the IBM Cloud, and that helps you to get the best of both worlds. These are more kind of like some references around the capabilities that we get with using Fiddle and by leveraging Kubernetes. If you want to know a little more about kind of like all the details of the architecture and things from Fiddle, the IBM research team has written a paper. You have the link here. You can easily access, download, and try to read that. So far, so good. So we look into the models. We look into like how we train them. And now let's take a look a little bit of like how we actually, some of the components that we are working on that helps you actually build those models. You guys that work with data science and things, that you guys have been using Jupyter notebooks? Okay. So basically this is kind of like a add-on to the Jupyter stack that I'm going to be talking about, and that enables you to scale that. For the folks that are kind of like new to notebooks, I'm just going to go very quickly and bring everybody to the same page. Notebooks kind of like a UI. It's more going towards kind of like a web IDE that enables you to do interactive development while you're building your algorithm or some code, etc. It helps you combine kind of like the code that you're trying to execute, some documentation around that, the data that you get back. You can start plotting that into like a graphs and things like that. Also enables like rich media. It allows you to make much more visual effects that document and then get your easy to understand all the complex algorithms that we sometimes work on. The good thing to understand here is when you are actually executing the code, what gets executed is inside a kernel. The kernel abstracts the code, it understands different languages, and abstracts the code execution. And when we start looking to scaling that and actually trying to build an analytic platform where multiple data scientists can come and use and launch notebooks, which was the case like for like Watson Studio, the DSX, Data Science Experience, we start seeing that the Jupyter Notebook had some issues or kind of like deficiencies, mostly because the way that historically it evolved from kind of like just a Python console to kind of like a more web UI type of interface. One of the biggest limitations, it was around like scalability. The way the Jupyter Notebook directly works, like without any add-ons to that, is that like all the kernels, so all the execution part, it will run on the same machine as kind of like a soup process. That gives you kind of like a limitation of like how you can scale. Even if you have a cluster of like multiple machines, you're gonna be constrained by the machine that you're actually running the notebook there. Also, in terms of like user ACL, or kind of like it's very like single user, so it's very hard to you to start kind of like be able to share and be able to get multiple people starting different notebooks as they're gonna start seeing each other, being able to kill each other kernels and things like that. With that in mind, we created the Enterprise Gateway. And kind of like in a summary, it starts to bring a lightweight, multi-tenant, scalable and secure gateway that enables Jupyter Notebooks to share the resources across Spark or Kubernetes clusters. A lot of like links to where you can understand more about Jupyter Enterprise Gateway. Around kernels, we have like very extensively tested with the IPython, R, Scala, and Spark kernels. We also, in terms of like, we initially started supporting the Spark and Yarn, and we recently added all the Kubernetes support as well. So now we can use the benefits of like being able to run and expanding a Kubernetes cluster. Some of the things that we try to concentrate in kind of like areas when we started looking to this was the optimized resource allocation. As you see now, we are able to run the kernels into kind of like all the clusters, all the nodes of the cluster. That gives us a very linear kind of like ascendant graph when we start trying to scale the number of notebooks and users that we can support. The more nodes you add, the more kind of like notebooks or users you can support. The main goal for us was to get this out, but also support some of the products that we have that run on the IBM cloud. So security was very important for us. So we have end-to-end communication, so like properly secured. And the multi-user, now that we started support, having the ability to support multiple users, we want to make sure that they will be running as themselves, so that there is no kind of like conflicts or basically that there is a sandboxing around that. Just some kind of like very high level, like when Alice starts opening a notebook, you will see that now she's starting to get a environment which has the kernel, basically a container running on Yarn, and it's running as Alice. When Bob coming, then he's gonna have the same kind of like sandbox environment for the kernel, running as himself. When we started looking to Kubernetes kind of like environments, which was kind of like the next generation of like the next generation of resource management that we wanted to support, we start seeing similar issues. We start also seeing that like Kubernetes will start trying to kind of like queue your pods if they start using some of like more resources. So you have to know beforehand, kind of like also how many kernels you want to use so that you actually pre-allocate the amount of resources for the whole container at the time that you bring that up. So we also try to scale to address all those issues, and you see that now with the support for Kubernetes, you get vanilla kernels in its own pod, and by then you don't have to waste the resources. You just allocate the resources when you need. When you close the notebook, then those are gonna get deallocated. Here's just like a very high level, like how things work is on the Kubernetes support. So you can have like your Jupyter notebook connecting to the enterprise gateway, or you can have it from the services. You can run kernels, kind of like we support Spark and Kubernetes, but you can also just have like what we call like a vanilla kernel running directly on Kubernetes. We also enables you to mix and match. So like, for example, if you're starting to do machine learning or deep learning and you need a specific framework, then like you can say that I want Python kernel running on top of like a TensorFlow, which then gives you all the infrastructure necessary and everything. So very quick summary. We talked about Model Asset Exchange. It provides you kind of like a curated set of models that you can start using, embedding in your application, and bringing the value of deep learning in a more easy way to your application. Fabric for deep learning, where you actually can start training some of those models. It also provides a consistent kind of like API for data scientists to work on models across different, train models across different frameworks. And Jupyter Enterprise Gateway starts scaling the notebook platform so that you can start building more big data applications, utilizing more resources, and sharing that across a bigger set of people. We talked about call for code, so just reference here. And I think that's about it. Open for questions, comments, or anything that you guys might have. No questions? Are you guys gonna give it a try when you get home?
Yeah.
Okay, thank you guys. Anything will be around, just
He will stay for the pizza, so you can also